Anyone online, can you respond if you can hear me now in the comments? Got it? All right. Sorry about that. We're talking about oysters, just to catch you up. So the three substrates that we focused on in this study were bag shell. So these are plastic mesh bags that are filled with recycled oyster shell, or in some cases with relic shell, also called fossilized shell, that are put in these bags and placed along intertidal zones. We also looked at concrete oyster reef balls. So there's an example in the picture there of what they look like when they're freshly made and then they become covered in oysters. And we also looked at loose shell, which is just pieces of recycled oyster shell that are placed without any hard substrate underneath. So the artificial oyster reefs that we looked at were constructed between 2006 and 2019. The monitoring in this study, it was conducted in 2019 and 2020. So the locations where we studied they were primarily located in Hillsborough Bay, But we also had some sites up in McKay Bay and one site that was located in Perico Preserve. So the blue squares on this map, they represent the locations of shell bags, and those were the most common substrate that was available for us to study. We also looked at the oyster reef ball locations, so shown in yellow. So there's a lot of oyster restoration along MacDill Air Force Base, and then also along 2D Island, and there's a much smaller island called Fantasy Island that has a lot of oyster restoration there as well. We were also comparing this to natural oyster reefs in the area, shown by the green dots here. And then we had two loose shell sites. One was on Fantasy Island and one was down in Perico Preserve that we included as part of the study. So our monitoring methods, we had a 1/2 meter by 1/2 meter PVC quadrat that we put down on the reefs. And we counted these in place without removal. So this differs from a lot of monitoring, including the monitoring that's normally done at FWC, where they remove the oysters off of the reef to make sure that we're counting all of the oysters because they can be hidden and buried a little bit down beneath. This was no removal sampling because, number one, we didn't want to harm these lovely oyster reefs that Tampa Bay Watch had made and remove the shell from the substrate. But also we conducted repeat monitoring at the exact same locations, and we didn't want to disturb these sites during monitoring. So it is very possible that we might have undercounted some of the oysters that were hidden beneath, but this was a no removal method. We also measured the shell height of 25 oysters per plot. We counted the density of gastropod predators recorded within the quadrat. So for instance, here is a lightning whelk actively eating some oysters in this photo. And we just focused on the gastropod predators because they are slow at running away, and things like crabs are really too fast for us to get an accurate count, but gastropods are slower, so we could get a more accurate count. And I should mention, we also looked at sedimentation on these quadrats. So what % of the quadrat was covered in sediment was another metric. And when it came to the reef balls, we were looking at what % of the reef ball had been covered in sediments at the bottom. Now we couldn't place a quadrat on the reef ball because of the shape of it. And so we just did some geometric calculations, looked at that, how much it had been buried in the sand, and calculated the equivalent quarter meter area on that reef ball. And we only counted oyster growth on the outside of the reef ball. It was just too difficult to see inside the reef ball to look at the oyster growth inside. So we completed 4 rounds of monitoring. Reefs under 2 years of age, we monitored twice per year. Others we monitored annually. And quadrats, they were placed in the same locations for each monitoring event, or we counted the same reef ball each monitoring event. Oh, I should mention that we did 10 quadrats per reef as well. We also surveyed elevation using a real-time kinematic global positioning system. It's an RTK GPS that's used to record elevation. We documented from the elevation, I could then calculate inundation frequency based upon water level data from Old Port Tampa for the 2 years of the study. Downloaded all of that water level data at a certain elevation, tied that elevation to the elevation of the reefs, and then I could calculate this reef is underwater 90% of the time, this one's underwater 60% of the time. And we also monitored spat, because it's important to know that the spat are available to have a successful reef. So we put out these T-shaped spat trees that had oyster shell hanging on wire underneath, and every month between April and October, we would go collect the spat trees and count the number of spat that had settled on the underside of the shells. So here are some of our results. This graph here, it is showing live oyster density here on the y-axis. And on the x-axis, this is elevation of the reef. So more negative numbers, they're lower elevation, deeper in the water. And these are higher elevation. There's 4 separate graphs because I'm dividing up the data between early 2019, late 2019, early 2020, and late 2020. And to give some reference to where the tidal frame is, this line here, this is mean tide level. And then we have mean low water and mean high water. So this shows you where the oysters are growing in the intertidal zone. So we're seeing the highest oyster density is found above the mean tide level. For instance, this graph shows it pretty clearly. So around 55 to 70% inundation, we're seeing very high density of oyster growth. But this does vary from round to round. So we see different patterns in late 2019, for instance. And it should be noted that on these graphs, it looks like oyster density just continues to increase. But when you get to a certain level, it's going to be beyond the available growth limitations of oysters. They need a certain amount of inundation. So if we did have reefs up around this area, we would expect to see this density eventually decline. But we just didn't have any reefs located in that very high intertidal zone. So I will be showing some models, but we did not include loose shell. So just to explain what happened with the loose shell reefs, we only had two. It was a low sample size to begin with. It just wasn't a commonly used substrate when we were selecting reefs. One of the reefs shown here at 2D Island, this was a loose shell reef that did have a lot of ample oyster growth on it. But our other loose shell reef this is a picture of it here. It was located in Perico Preserve in Manatee County. And it was an inlet into this constructed pond here. That was all a restoration project. And it turns out that the shell, it was largely placed there as a shoreline stabilization feature, not necessarily meant to be a restored reef. And we also found that the water quality and spat availability just wasn't really prone to oyster settlement in that area. So we didn't have a lot of oysters settling on this area. I don't want to go on the record of saying there's no oysters in Perico, because here there's circled in red. There are oyster reefs around Perico. There are oysters that grow there. It just happens in this one location here that we didn't see a lot of oyster growth in the inlet to this constructed area. So we went from a sample size of 2 kind of down to a sample size of 1, and that wasn't enough to complete any modeling. So I'm not going to do any modeling with the loose shell type of reef. But for our other 3 substrates, I took the same data that showed live oyster density, and now we're modeling it using a generalized linear model to look at how oyster density changes with elevation and also by the substrate type. So shell bags are shown in blue, oyster reef balls are in orange, and natural reefs are shown in green. So around the mean elevation, oyster density was significantly lower on the exterior of the oyster reef balls compared to shell bags at mean elevation. So in other words, this orange line here, it is significantly lower than the density that we see on the oyster reef bags. However, this does change with elevation, and you can see it when you get towards the higher elevation levels, they approach each other. And also on natural reefs, we're seeing similar oyster density compared to the bags of oyster shell. So there is a positive effect here of elevation on oyster density on our 2 artificial substrates, but we're not seeing this effect on natural reefs. And again, these trends, they do vary across the monitoring rounds. We do see slightly different trends each round. So the data here, this is focused on the size of the oysters. And in this case, we're seeing at the low elevations now, that is where we see the largest oysters growing. So on shell bags, for instance, that's shown in blue, this trend is especially apparent. So at around 93% inundation in the very deepest water, we're seeing much larger oysters growing. And then when we convert this data into a similar model, just looking on mean shell heights, we're finding there's significantly larger oysters at lower elevations, especially in the early part of the year. But this relationship is less steep in the later part of the year. And we're not seeing any difference across the substrate types when it comes to shell size. They are pretty similar across the 3 substrate types and also on the natural reefs compared to artificial reefs. So another way of looking at the shell size data, this are histograms from 2 reefs. They're both shell bag reefs. They were both made in 2016. They are, one's in Fantasy Island, one's nearby in McKay Bay, but they're at very different elevations. This is a high elevation reef at around 62% inundation. This is a low elevation reef that's underwater 95% of the time. So at our high elevation reefs, this is showing the size distribution of the oysters, and they're very small. They're on average, it's around 25 to 30 millimeters size oysters. And just to put it in perspective, this line here, it's showing where 76 millimeters or 3 inches, that's the legal size for harvesting oysters. Not that you can legally harvest oysters in this area, but just as a comparison for how big legal size oysters are and how small the oysters are that we're seeing growing on these reefs. They're pretty small oysters. And then on the low elevation reef, we see a much broader size distribution. Some of them get to be up to the legal size. And we also see oysters that are probably indicative of an older age class that are growing on the subtidal reefs. So our other metrics that we looked at, the predators, there was a higher gastropod density on the lower elevation reefs. So in deeper water, we're seeing more gastropods. We're also saw more gastropods on the oyster reef balls compared to the other substrates. And then in terms of sediment burial, there was more burial. Here's a picture of what it looks like of a site where there's a lot of sand covering some of the oyster bags. There is higher burial on the low elevation reefs as well. So in summary, if we were to put this all together as a diagram for what the trends are for oyster growth, again, we didn't study the very upper limit of oyster viability. So this is thought to be around less than 40 to 50% inundation is outside of the growth zone for oysters. We didn't have any reefs in that zone, but we did have two pretty clear distinctions between high elevation and low elevation reefs. So high elevation, around 50 to 60% inundation. They have very high density small oysters. And the stressors that these oysters have to face include, they have reduced feeding time because when it's low tide and they're exposed to air, they can't eat. They have to deal with heat stress during that time, especially during Florida summers. They have to deal with desiccation when they're exposed to air, and they're also competing for space because it is such high density, abundant oyster growth up there. And then in contrast, these lower elevation reefs that have around 80 to 99% inundation in our study, they had much lower density, they're much larger oysters. The stressors they have to deal with include predation, sedimentation, I'm saying et cetera, because there are other stressors that weren't necessarily included in this study. There are boring sponges that like to live on oysters and will cause bioerosion. They're more common in deeper water. There are diseases like dermo that are more common in deeper water. So there are more factors beyond the ones that we studied in this study that can impact oyster distribution along this elevation range. So brief mention on the water quality in oyster spats. The water quality up in the area of Hillsborough Bay and McKay Bay, we were just doing point measurements of water quality every time we were at these reefs, but the salinity was always within the range of the brackish salinity that the oysters like to grow in. So the water quality was fine in terms of salinity. The salinity at Perico Preserve in that one channel where we were sampling was rather high for oyster growth. And we did see ample spat at all the locations. Again, except for Perico's Preserve in that one channel, there was not a lot of spat. So this is kind of supporting what I said earlier about there being enough spat within Tampa Bay for oyster settlements, with the exception of some locations that might not be suitable for oyster growth. And in terms of spat peaks, in this data set, sometimes you see one peak of spat abundance per year. Sometimes you see 2 peaks, and we did happen to capture that, where we had 2 spat peaks in 2019 in June and August, and then in 2020 there is 1 spat peak in June that occurred. So to sum this up for substrates, we did find that there was lower density of oysters on the oyster reef balls than bag shell at that mean elevation. However, it differs at other elevations. There's no significant difference in shell height across the substrates that we looked at. But in terms of selecting substrate, often selecting for oyster density or oyster size might not be the leading metric that you're thinking about when selecting for substrate, because things like wave energy and erosion and sedimentation at the site are really important factors. These oyster reef balls, they are much better at withstanding high wave energy. They're much less likely to be buried because they're so much taller than the bags of shell. And so they're often chosen for these high wave energy locations. And then some substrates, such as the loose shell, they are less able to withstand high wave energy. And we saw this reef erode before our eyes over the course of the study, just anecdotally. We could see it, edges of the reef falling into the water. So other factors for selecting substrates include costs, logistics of deploying things like these large, heavy concrete oyster reef balls. And also increasingly, people are starting to focus on the use of non-plastic materials as a component in artificial reefs. I'm trying to emphasize that. So conclusions on the elevation portion. We do recommend a broad range of intertidal elevation. There's benefits to both. So those high elevation reefs, they do have a very high density of oysters. They're in a good position for sea level rise, as a benefit to that. But the low elevation reefs have the benefit of, when they do make these large oysters, they're disproportionately important for filtration capabilities, for reproduction and shell budgets. They're really important to the oyster population as a whole to get these large oysters growing. So really having a range of elevations would help the population as a whole. And in terms of location, our whole study area up here did have appropriate spat and appropriate water quality. So it was good to see that wasn't a limiting factor. And it allowed us to focus on other things like substrate and elevation. So the spat, it wasn't limited, but it was variable in space and time. And so the timing of putting out these substrates, you can time it to put out the substrate so you're ready for the next spat fall. And that will allow the spat to settle on the substrate rather than other things like barnacles or algae to attach first. We did see similar oyster growth on the artificial and natural reefs. So that was nice to see how comparable they were with the natural reefs. And another recommendation we made is just for a broad range of locations is good in any estuary. Because when you have localized mortality events, whether it be from the next hurricane or a freshwater pulse that ends up killing off a local population of oysters, you want to have other populations in the bay that survive that can be a source of spat that can then help repopulate areas that see these local die-offs. So it's important to have many areas of successful oyster population around any bay so they can help repopulate the bay when needed. So I do want to acknowledge that this was a TBERF project. So thank you for the TBERF funding. And there are many co-authors, but also many other people that helped out with this project, especially on Tampa Bay Watch as well, because these were largely Tampa Bay Watch reefs. And with that, I think we have a little bit of time for questions, perhaps. Yes.
Question, you were analyzing the spat for your recruitment arrays. Did you include all shells on both sides, like top and bottom? Or did you do some exclusion?
Yeah, just the center shells. Yep. Yeah, so we excluded top and bottom and just, oh, repeating the question. The question was, did we count spat on all of the shells on the stringer? No, we excluded top and bottom because they're more exposed to other factors like predation, and we just did the central shells for counting spat. Yes. I did start looking for any impacts. Oh, so the question was, did age impact any of our metrics that we were looking at? I did start looking for any factors of age, and it just turned out that other factors were much more influential, especially elevation. It just kept coming back to elevation being much more influential than age. And kind of as a side effect, the degree of sedimentation seemed to be much more sedimentation at the lower reefs, especially if they were older, they had more time to be sedimented. But it didn't rise to the top as being one of the more influential factors for age, no. And I think it's also worth pointing out that a lot of these oysters, they're young. So you're kind of getting a new crop of oysters every year. So if you're looking at live oyster counts, you're probably just looking at oysters that settled within the past year. And you're not really getting years and years and years of live oysters on that given reef. Yes.
So on your per meter squared, did y'all extrapolate that just that you should calculate one?
Yes, so it was, the actual area was 1/4 meter squared, and then we extrapolated it to make a metric of oysters per meter squared, just to make it comparable with other metrics that aren't generally published. Yes, Ed.
Well, you kind of lead to the term recommendations for citing different locations for restoration. Or given that, like, historically, we had a lot of subtidal oyster beds in the bay, that we proposed new recommended acreages for some of our basins, making clear that a multi-pronged strategy, by restoring subtidal areas, but following areas, higher elevations, and supplies back to destination where subtidal beds might be affected by location. Like that needs to kind of shine through as we think about developing oyster restoration. Oyster restoration targets.
Yeah, so Ed was mentioning the importance of, I like the Melanie Parker, who studies oysters now down in South Florida. She phrases that as not putting all your eggs in one basket. And I really like that idea, because we do have these local mortality events, and sometimes it can be hard to predict which population will be more successful from year to year, if it's the intertidal or the more subtidal, or which bay and which part of Tampa Bay. So having a diversity of reefs and locations and elevations, I think is important, especially when we're looking at uncertainty of water conditions over time. Yes.
How did you sort of find you touched on this, but how did you quantify sedimentation of elevation of the reef? That was like an initial and then end of project measurement for elevation of reef, and I'm just curious how you measured, like how you quantified sedimentation.
It was within the quadrat, what percent was sediment? A visual estimation for the quadrats. And then for the oyster reef balls, we knew how tall they are standardized. And then we measured how much was left visible above the sediment, and we could calculate what percent had been covered by sediment. Those were the two metrics for sedimentation. Yes.
Just, I mean, generally solid. I was curious if you're considering what
The question was, are we going to go back and look at loose shell? Yeah, if I could go back in time, I would add more loose shell reefs to our sample size. I would love to. We're not currently doing a similar type of project right now, but I agree that the loose shell would be very interesting to study. And it is commonly used, especially in subtidal reefs, with deploying large amounts of loose shell over a large area. That there is a fair amount of study on the subtidal reefs, especially in the Panhandle. But yes, down in places like Charlotte Harbor, there is a lot of loose shell that we're not studying, but others hopefully are studying that can add to the body of science on that.
There may be a question online. If there's any online questions, you can unmute and ask.
Yes, this is Randy Edwards. You hear me?
Yes.
Yeah.
Question is that these factors, these parameters that you have modeled and measured and modeled and so forth, don't you agree that it might be very different in a very different environment? You're working in a kind of a mesohaline bay environment, whereas oysters grow and are very important in more riverine, lower salinity, more highly variable salinities. Do you have any plans or intent to look at that, look at those factors in those kinds of settings?
We ourselves do not, but we do like to, there's a lot of groups doing oyster research in Florida, and I can mention and give it a mention to the Oyster Integrated Mapping and Monitoring Program, which my group also co-leads at FWRI, where we're compiling information from all of the groups that are conducting studies such as this across Florida, because there's a lot of individual studies like this that are focused and often provide base-specific results. But it's really when we start doing a literature review of all of these results that we can see the general trends. And it's absolutely true that oysters face very different conditions in the tidal creeks versus an intertidal zone versus subtidal oysters, that we can compile them all and start seeing the trends and differences among all of these habitats. We're not working on it on ourselves, but we do compile information as part of the report for the Oyster Integrated Mapping and Monitoring Program that's available online. Thank you. So I can clear there.
Thank you, Kara. Our next speaker is Dr. John Davis, from Drummond Carpenter, and we'll talk about invasive species workflows.
One second, I got some logistical things first. Okay, so this is the part of the TAC meeting where we want feedback from everybody. So we want a lively discussion. Bud's going to talk a little bit, but we really want to hear from you all about this potential product and how it can serve you and your needs. So thanks.
Hi, everybody. I'm Bud Davis. I'm with Drummond Carpenter. And like Marcus said, yeah, this is all about feedback. We don't have major results to present. This is about presenting a product that's in development for invasive species indicators. So like before I even get into this and like start dumping figures and maps at you, like if y'all could think about what invasive species data set you would need, what metrics you would need, what would an online dashboard that could help you out with your technical management of invasive species, what would that look like? And just think about that for a second before I bias you with what we did, because what I really want is your opinion and your feedback. And I'm thick-skinned. Y'all can just pick apart what I'm going to show you and say, change this color. That is more valuable to me than if we don't get any feedback out of this. So yeah, have at it. Let's see. Can I get this to go? There we go. So a little bit about this project is it came out of this Hack the Bay event that the Tampa Bay Estuary program hosted in January. So this was a one-day hackathon where a bunch of teams got together. They're all different types of data we had, and you had one day to come up with something. And our team put this together down here in Tampa. And that's our picture from at the event. We had a really great team with our eco people and our data nerds. And so we really got into this one. And what we came up with is this like idea of contextual invasive species management. And for us, what that means is we're not just looking at where the invasive species are, but where are they in regards to your landscape value? Where are they with regards to high priority, ecological habitats that you might want to focus your activities there? Because what we wanted to do was make a tool that would let technical managers prioritize maybe their annual invasive species removal or management activities. And so this would ultimately get at kind of the metrics and maps that would let you do that. So a little bit about it is there's two primary data sets that feed into this. And the primary one on the invasive species side is this USGS NAS data set. So that's the non-indigenous aquatic species. It's from the USGS. It's a really high quality invasive species observation data set that has geographic locations that are tagged by quality as well. They're really detailed. They pull from a number of sources. So they're doing a lot of this legwork for us in terms of getting the raw data together. And what's really great is they put it together in an API. And basically that means they get this data, they get it formatted, and they put it in a database that's online in a consistent format that you can build tools off of. So we don't have to do all that legwork ourselves. This is up to date. It's actively maintained. They're constantly rolling in new data. And this is kind of what it looks like just on the right. It's a great data set, but not great data products. There's not nice maps that can tell you, hey, you got to go out and get it, get these invasive species here. It's really a raw data platform. And then the other key data set that we kind of feed into this is the Fish and Wildlife Florida Landscape Assessment Model. So it's a land value model, simple values 0 to 10, and it's really just landscape value in terms of ecological benefit. And they combine a bunch of different variables, but it kind of weighs, hey, where's your natural habitat that provides conservation access that might host really unique endemic species? And this is updated annually. So these are two data sets with pretty good update frequency that kind of let us get at this idea of where are the invasive species and where are they that matters most. And so at the Hack the Bay event, we had these two primary data products that we presented. On the left was one of these estuary program kind of style report cards where we have it broken up by bay segment, and we colored it initially just green, red, blue, and that was just comparing invasive species abundance, which is the number of invasive species observations, and invasive species richness, where do you have one invasive species or do you have a lot of different invasive species? So we had two report cards for that. And we focused mainly just on the local bay itself. And then we also made this dashboard that came up with hex bins that would prioritize area for invasive species management, where we took the abundance and richness metrics within that hex bin and we combined them with landscape value and then ranked those. So your number one area to prioritize would be areas where there's a lot of invasive species, a lot of different types of invasive species, and a lot of high land value in terms of ecological benefit. So this is what we made at the event. And then we've been working with the Tampa Bay Estuary program to kind of refine that since then. But what we really want are the technical manager feedback in this refinement process. So how do we go from this to something that's actually really useful for y'all? So we've done a couple things. One is we expanded the AI, the area of interest, to the larger watershed. So we're not just around the bay itself. We took this all the way out. We still have our bay segments that lets us group this. We've also done a lot of data exploration. I think one of the big things that we've kind of found about this NAS data set is that it might actually be better for kind of your terrestrial areas. Out deep in the bay, it might not be quite as good for things like your invasive fish species. So that's a potential issue, or ways that we can improve it going forward is to bring in additional data sets that might not be on that USGS data set. So we've done this data exploration. We looked at, what are the sources that are feeding into this data set? And really what we found is it's only a few sources that are making up 95% of the data. So for Tampa Bay, 10 sources make up 95% of the data. Most of the big two are iNaturalist and then the FWC's Aquatic Plant Survey. Those are two of the really big ones. iNaturalist is one of these citizen science initiatives where people can go out, take a picture of something, report it on their phone. It's great. You get that geographic information. you get photo verification, but also you're going to be biased because this is going to, be where people are interacting with invasive species, not necessarily where invasive species are. So you are going to have a little bit of that type of bias. This is what that looks like through time. You're also going to have this like temporal bias component too, because this reporting isn't consistent every year. Some of these are one-off events that dump a lot of data into the iNaturalist database, like this 2012. I forget what that abbreviation is, but you have these one-off events that dump a lot of data. So it might make it hard for an apples to apples comparison one year to the next. So you just got to kind of know that about this data. You can see iNaturalist really picks up here 2017, 2018, and then there's pretty significant year-to-year variability on there. The Aquatic Plant Survey last reported came out 2018. So if it comes out again, we might get a backlog, but right now I'm not actively updating on the database. Also did data exploration on this FLAM dataset. It does look like a really good dataset to use for this rather than try and reinvent the wheel. It does integrate a lot of, the major components of what you would want in a landscape value metric. But for the Tampa Bay itself, it might not be the best at capturing these aquatic environments. It matches the wetlands really good and captures that value. A little bit less good at capturing the value of oysters and seagrass. So you don't see those pop up as high landscape value areas. So landscape values up here, seagrass down here, you're not really seeing a seagrass component. So being able to maybe update this landscape value with some of these aquatic metrics for landscape value, that could be a potential improvement going forward. For our report cards, we've gone from this, red, green, blue, which we kind of understand now is more of an action. If red, you do this. If yellow, you do this. If green, you do this. We've shifted now to a different color palette because we're not tied to any specific actions. Now we're using kind of this, white, teal, blue color palette. We've refined it in a couple of ways. Now we've got a total column over here, so you can kind of see that potential years with reporting bias. Those should pop up when you're making, cross row comparisons for different bay segments. We've got this remainder lower Tampa Bay for some of those small ones that previously we might have been excluding. Now we've got those grouped down here. We've got this so you can view the raw data, or if you want to view it as a percentile for the total data set, you can view it a couple different ways. But then we've spent a lot of time really working on bumping up the dashboard's capability. So it's not just showing 50 hex bins where you should do stuff. Now it's showing a lot more of the data that feeds into it. And we've expanded that all the way out. And I'll go into that in a little bit. But I just kind of want to touch on this today. And really, I want to come back to this after I show you what we've got and then have a discussion. But we need to know, what are the invasive species management activities that you're doing now? What are the management activities that you want to be doing? What data do you need to do that? And what metrics do you need to track your progress, to show that you're meeting your goals? So things like that. Those are really, I think, the 4 feedback things that I need from y'all most. But then also individual feedback on these dashboard and report cards. Make it look like this, make it look like that. That would be really helpful as well. So this is now, I'm just going to show you what the dashboard looks like. So it pulls up to a nice overview page, and we'll have a little bit more information here. And then you can actually go to the map. So this is an interactive map with interactive filters over here on the left. So this default view, it's showing the FLAM data set. It's showing all the individual species observations, colored by their different type. And then the circle size is the accuracy. So we get that. Is it accurate down to a specific location, or is it, approximate, which is usually at like a water body scale, like a lake scale, canal scale. Filtering capabilities, you can prioritize the number of hex bins you want to see. So if you don't want to see 50, if you only want to see what are the 5 most important areas, this can help target those. You can filter it by water body segment. You can change the year range. So if you really only care about data from the past couple of years, you can do that. You can do seagrass overlays, which didn't pop up great on here because I've still got the FLAM on. You can filter it by municipalities. So we've got, I think, the major TAC member municipalities on there. You can look at the different groups. You can even search by a specific species. So like This is, now we're in Tampa and we're looking at where is the water hyacinth and showing the hex bins, and we've got it, now really showing, hey, your number one priority area is probably up here. You can actually go to the individual data points. It'll tell you the date of observation, where it's coming from, what it is. On these, hex bins, you can go to those and see, hey, this is your number one ranked hex bin. You should really investigate invasive species improvement activities around this area. The hex bins aren't necessarily supposed to be, rigid boundaries that you follow. They're really just to guide your eye and guide your general planning. And it's got the density, or it's got the, mean FLAM score, so the landscape value score for that hex bin, and then the density of invasive species observations within there. You can export the data. So when you get it, right to say, hey, we want to target X, Y, and Z, then you can export it and you get a nice little CSV of the, filtered data set with the locations there. So that's the dashboard. Report card side, open to a lot of feedback here, but right now we've got it making abundance and richness report cards. So this is one showing the raw values. I do think the abundance probably tells you a little bit more of the story. The richness, I think, can tend to focus on, maybe some repeat measurements or maybe some bias that you actually see in the reporting data itself, but both could be potentially be useful for your landscape management or your invasive species management. So that's based on the raw values here. We can also color them by a percentile. So percentile, maybe highlights, the big, large trends, I think, a little bit better versus these tend to focus on the raw values tend to get skewed toward the single values. Percentile kind of shows it a little bit more generalized. We can also change the color scale. This is a very muted one, but also there's kind of this unintuitive high values are blue thing that we've got going on, where we want your eyes to be drawn towards, the big intense values, but, they're bad and they're high. And so should we use something that's more like purple green? We're open to feedback there. But really kind of where we are now is, what do we want these to be? In the report card, we want to be big picture. So what do we look like watershed year scale, even in this context of known spatial temporal bias that we've got in the data? And then the dashboard, we want that to be pushing action. Where do you prioritize these projects? That's the where and the what. And then potentially even setting it up for future functionality to be kind of an early warning system. So this is the first time we observed this one within this watershed. You should go take action here. Timeline for all this is today. I really want to get this feedback from y'all and then implement it by the end of the year, hand it off to the Estuary program, who then, starting kind of at the beginning of next year, can implement maybe some more additional functionality that's not in the budget for this project, and ultimately have it up and running kind of mid-2026. So kind of back to this is, what are the main questions or main things I need as we kind of go into this discussion period? What are you doing? What do you want to do? What data do you need? What metrics would be helpful? And then feedback on the report card and dashboard. And with that, yeah, I'm looking forward to hearing from y'all. Thank you.
Do we love it? Do we hate it?
Hi,
You have a lot.
that's great.
That's-
So when you talk about invasive, you're not limiting this only to exotic species. Anything that can turn invasive should conditions warrant them.
That's a good question. I wish my eco people were here because they could answer that better than I could. I do think you see in the data, there are some one-off exotics, but it's also pretty clear when you start diving into the data. So the question is invasives versus exotics. How do you differentiate between those? I think when you start playing around with the data, it becomes pretty apparent what's invasive and what's exotic. You'll see the one-off exotics that it's like, wow, this person saw something very weird and took a picture of it and it got ultimately in the database. And then you can also see in that data, man, we are dominated by these invasive plants along this watershed. And it starts popping out, I think, once you start interacting with it. But I don't think it's any functionality that, we've got built in now, or that, the USGS is screening for when they're updating their site. It's not, a parameter that we can currently filter for.
I kind of think it's gonna be a little hard for us to create sort of an overarching return, because I think if we ask folks in the room what you consider an important invasive metric, it's gonna be very different. FWRI, FAM is looking at fish, the district is doing habitat restoration projects, we're looking at things pepper, lead trees. So I think this is a great forum to have that discussion. And one of the things I jotted down is like, it'd be great to have like a top 5, top 10, of the who's who in terms of invasive species, and who that might impact the most in terms of like, why do I care about lionfish necessarily? And maybe I'm more concerned about, and you can even go so far as to say, let's look at the habitat master plan, and where we see, the greatest habitat loss in salt line. So one could say that mangroves are an invasive species. If your focus is let's restore or preserve salt line. So
Right.
I think it's a good form. I'm not sure how we move to the point where we can have kind of a overarching report. It really does depend on your control.
Yeah, and these are discussions that Bud and I have had the duration of this project. Like, what is this product really trying to do? And he kind of paraphrased it as just sort of, I see it as kind of two objectives. One is like this overarching status and trends of invasives or exotics over time in the bay, which is good information, but it doesn't lead to action. And then the question, well, what sort of actions do we want people to pursue? And that's kind of why we're bouncing this off of you all. And one of the key things I was thinking of is, this concept of like, this is the first time we see this particular invasive species, kind of like an early warning thing, because that is an instance where you might actually be able to do something about it before an invasive becomes really entrenched in the landscape or in the water. But again, that's different between versus an exotic or an invasive, or like what should we be looking for? And so I like this concept of like, maybe there's a top 10 list of invasive species that we want to add as a filter, or if something is not even here yet, if we want to set it up in a way that's like, there's a big alarm that goes off on the dashboard when there's this first instance of this particular thing that, like Python, something like that,
I think that's where this is my personal opinion. I think that's where there's the greatest value in this. I remember back with green mussels getting bay and everybody freaking out, they're going to take over everything. But that was one that just kind of came on the scene. If we have like an early warning type of system, even if it's like an iNaturalist type of citizen science.
Yeah.
I mean, we do that anyway with things like Macintosh. We really rely on like the captains and the every single day to tell us, hey, something's not right. That to me, I think has a lot of value. That transcends everyone's kind of organizational mission. It's important to know what's coming, maybe the issue.
Yeah. Yep.
I was curious if you guys see you all a lot of it's a lot of this really excellent stuff. They're also that's time for questions second that you just insightful, helpful guidance for like getting this to biasing towards action, just finding ways to incorporate like the manager municipalities. Aside from like aquatic and terrestrial invasive species, there's a lot of industry going on that may or may not be noted through things like iNaturalist and observational like citizen forward things. And so in a lot of these like natural areas, there's a lot of very minutiae scale monitoring that on something like marrying that to like the land management, maybe like parcel boundaries, stuff like that, densities. I don't know. That's kind of spaghetti at the wall, but finding with areas to like municipalities are doing track their basically.
Yeah, so the two comments were, the first, have we worked with the Florida Invasive Species Council? No, we haven't worked with them, at all on this project, or looked at integrating any of their products, but I think that's something, worth looking into, like how feasible is that to bring that in? And the second comment was, how do we actually work with the land managers here? And I think that's something that y'all will know better than me, is how do we actually like integrate that and make this more actionable? I think bringing the land value in like does that a little bit, because it does bias you towards like these natural areas that do have, really high ecological value that you do need to preserve it and think about. But then bringing it into the bigger context of municipal invasive species management, I think that's really the tough hurdle to get over from dashboard to action. So.
Yeah, and just to follow up on that too, we have a pretty small budget for this project, and I'm not giving a throwaway answer of like, we can't do everything, but with that in mind of what we can reasonably accomplish in this time frame, I am working a lot with them to try to communicate that what they produce and provide to us should be in a state where we can sort of plug and play different data sets as needed. And so if there's like something like parcel boundaries or land management jurisdictions that are of interest, the idea is that we could incorporate those in the future, if that is a priority for this product. The other thing too is, he noted that we're missing a lot of the subtitle habitat or subtitle areas in Tampa Bay. FIM data, which we'll talk about next, is a great source of information for looking at invasive fish, for example. That's something that's clearly missing from this. We're aware of that. So when it is handed off to us, we are planning on further developing the product to fill some of those gaps and address any future needs that relate to how we want to parcel up the information that takes into account different topics.
Good point in terms of it's in parcel level, we did a lease that they developed to where we have identified restoration opportunity listed public and private conservation spaces. Public regulated properties. One of the problems. That's sort of integrated this because that's. Volunteer very basic stuff and it's problematic data that made this consistent. It probably amazing like really are super problematic. It's like you balance this. Yep.
So one of the data sets that you mentioned, one of our online folks, Estuary from Estuary, also mentioned, which is I've got one database from FWC that monitors on these, so that would be done with that.
Great. Yeah.
So what? All horses. But maybe in comparison to how Cornell the bird data is because I know they already have like a formula calculator, not that it's recommended, but in order to kind of adjust that so that you're not overcounting. So get everybody's out at our Robinson Preserve their favorite. 200,000, 300,000 people. That's huge.
Yep.
Yeah. Yeah, these citizen science data sets is like kind of newish territory for the Estuary program. We know they're out there. And when we were doing the hackathon early this year, we were like, use whatever data set you want. Like, we want to see what is possible. And as you rightfully mentioned, there's issues with some of those data sets in terms of reporting effort and whatnot. And I'm personally interested in how we can make better use of those data sets because I know they are a treasure trove, but they don't come without their limitations. So that sort of feedback is great to help us conceptualize how to operationalize the use of these data sets into some of our routine reporting products. So I appreciate that comment.
Yeah, I think one thing we were kind of thinking at, and like, again, so the question was, how do we, adjust for this potential like spatial temporal bias that's just from where people are and where they are a lot at this time, that's going to influence your reporting on invasives to try and get at a raw trend of the true trend from this data. And I think it's a really hard thing to do. And I think it's something that we can't do within the budget of the project right now. We can do simple things. So one thing, we kind of talked about doing was, what if rather than, reporting these values or percentiles across the whole data set, you just look inter-year and you assume 2018 might look similar to other 2018 in this bay segment looks similar to 2018 in this other bay segment, and do comparisons that way. I do think you lose some of the big picture trends. So maybe you do that over like 3 or 4 years instead. But it's really hard. And like, do we want to spend all this time massaging this data to make it look away? Does it actually make the value true? Probably not. Does it make it slightly truer? Yeah. Is it better just to kind of always have that caveat and like hold that? Because we might care a lot about where people are interacting with invasive. So it's tough. There's not a good answer, and there's probably not a good answer that we can implement under the current scope. But it is a way to potentially improve these products going forward.
Yeah, that's something.
Yeah, so let's see. Yeah, so you can search by group. So here's an example, right? So the question was, how can you search within the dashboard? And right now we've got it. So you can filter by group. So if you want to see just plants, reptiles, mammals, you can filter for that. So that takes care of it. If you want to search by a specific species name, you can do that. If you want to do a common name, you can do that. So that kind of should hopefully make it a little bit more easy to use, or targeted towards a specific species. So yeah, we've got that functionality built in.
And the dashboard's not online yet. We're working on that. That's Bud showed the timeline sometime next year. We'll see. But we're still working out some of the functionality there. And so yeah, now's the time to sort of get the feedback and make this what we want, because we're still actively working on what this looks like, but it probably will be online early next year.
Since you have limited resources, I would say better thing is to focus more on that word less than not sure who that document to anyone in this room. As far as public, I'm not sure they would have like the small caveats we just talked, but I think the data would be useful. And I don't know if you talked to Mark Walton, who's my group district, but in the last few years we've been doing geodata. We've created a geodatabase, looking at old restoration projects. Basic species is one of those components. So I put you in touch with Mark. Talk more about that. That might be a good data source if we did.
Yeah, that'd be great. So
one comment about the report card. This part of this exercise is filling the indicator gaps for our program. And while I agree that the report card in itself is not necessarily super actionable, it is part of this bigger mosaic of indicators that we use in the program. We are working towards ramping up the synthesis of those things, and we kind of wanted our report card to follow a similar format as our existing products. So when we do say, well, what's the health of Old Tampa Bay? You can look at the different pieces, and just parceling it up in that spatial context is useful for that. Also forthcoming.
There's a long range challenge, but it's really it's a report card. With the data, all these different figures involved.
One square for the whole day. How does that sound?
I just want to sort of reiterate a point that I'm not sure, this really make it clear, but so you mentioned FISC, but whenever you get this product to a place where you either want more feedback or, you're ready to roll it out, it needs to be presented to the SISMA, the Cooperative Invasive Species Management Group, because they'll have some ideas, probably better than this group. Like we all have like little tiny pieces of it, but they're sort of imbued.
yeah. Great, yeah.
The two really good is for invasive plants, because you can do something about those. And the other thing that I would really like, and we mentioned this, is the early warning, like the pythons. I mean, we are warning, it's a possibility. So had to have warnings for those, because, I mean, even if they are animals and they move around, if we get a general location, we can do something about it before it spreads.
Yeah.
And I think that would be a really useful part of this.
But just for the recording and the comments, so yeah, partnering and presenting this to the different invasive species group, I do think that's an important next step. And then, two of the big things from the dashboard are plants, very actionable, and then early warning. That's been consistent feedback that would be good functionality for us to at least have that toggle to say first occurrences this year, first occurrences for this time frame. Give people the ability to show that and see what the list is for that and where it is. So yeah.
So for your prioritization, if regardless of kind of what we put on, it's always calculated based off of the density of the calculated included and the
Landscape value. Yeah.
because I'm wondering, given interest in that there, knowing that different types of invasive species will differentially affect those things instead of kind of just having it for everything together, having the prioritization and it be able to allow you to say, okay, specifically for seagrasses, we know that here's a suite of invasive species that differentially or disproportionately impact seagrasses. So they're like the biggest things to look for.
Right.
Working for seagrass. Now I'm taking this prioritization based on what we know about seagrass. And that is also then coming up with a consistent report card, because you kind of say from the front end, we know these invasive species are problems with seagrass, and these are problems with waste groups, wetlands, etc. like
Right.
that. And then you could always have that as a consistency of track, but allowing that kind of customization in the prioritization dashboard would then allow people to get more explicit.
Yeah, I think so. The comment was, how can we make the prioritization more useful and targeted rather than just kind of going off two metrics? And I do think that's absolutely an area to improve and iterate upon. I think probably where we are now in this project, the way to get at that is so it updates based on all of your filtering. It does your prioritization based on that. So if there are species that affect seagrass, you can filter by those. And that will update, where you should prioritize. It'll still have the landscape value, which we know probably doesn't capture seagrass effects as well. But you can also just turn off the bins and use the map itself to kind of guide you. The bins are more to draw your eye. It's not saying strictly to go out to this hexagon. It says, hey, there's probably a water body. There's a little water feature here that's got this issue, or there's some area where people are that they're commonly observing this. So I think that's probably where we can get it to for now. I think ultimately, if you build out these components and say, hey, these are the ones we want to target for wetlands, you can have that functionality, built in and do the wetlands target or the seagrass target and see how that pops up. But that's a great idea. Yeah. There probably isn't a perfect report card that you can make, to be honest. Yeah.
Programs, monitoring or basis.
Doing what type of monitoring?
Median.
value. Or
It's a part of our offer. We're doing. Program. Just needed. It's their goal.
or target species.
Summarize for an inventory, I don't know that yet. On abundance, but present happens. Yeah, so we could use that. But the catalog of, the species that are available in the library, it's growing every day. Maybe it's not. And, sure, yeah.
Using something that has, narrow down what I'm going to focus on, and given water body, whatever. You could apply some nice new techniques for monitoring that spread. I mean, it could be it's intensive as any sampling, right? Set other area, but areas on that.
Yeah. So the question was, have we looked into or incorporated any eDNA analysis? And the short answer is no. It is something like we can look into and see if there's any like really easily accessible data sets that could potentially be integrated in the future.
The majority of them.
Yeah. A long tail, a lot of data sets, but there are other parts of the country that have pretty robust eDNA monitoring program. Looking forward, I mean, that's a great tool for like early detection, if you believe data. But
Yeah, a lot of the application is on TA species, as is you're looking for that rare occurrence.
Yeah.
It could be the flip side of that, could be the opposite. That encouragement.
and it's pretty much limited to aquatic habitats. Yeah, that's. But yeah, that's true.
There are other Connecticut and Dawson area they use and see the generic work. Yeah. That particular ecotype of Dawson area turned out it's names. There's some of that for too. I don't know how you would incorporate that into that works.
I'm gonna put this on the list. of
Yeah.
things, Yeah.
Well, my dad.
I'll let y'all handle it.
There was one more comment online from Megan Blanchard talking about the Suncoast SISMA. She mentioned they might have a specific early detection after response plant test. So it might be worth looking into, and she put a link in the comments. I don't know if you want to expand on that, Megan.
Not at all. I was just inspired by what Courtney mentioned from FWRI and what y'all were talking about in the room.
Okay, thank you.
I just more of a comment. I pulled that right now. It's you said. I think it was. Reduction in funding staffing, that's just one of the things that's tracking you already are, or some of the things which.
Yeah.
Isn't all.
Yeah, absolutely. So the comment was just be mindful that these USGS data sets, they exist now, they might not always be in the future. So continue to do the data investigation, make sure we know what the actual underlying sources are, and have some plans to make sure that we can incorporate those.
On that note, should probably move to the next speaker. Any final comments, feedback for?
I'll be in the back. I've got my card. Please reach out. Bud Davis with Drummond Carpenter. So these are all great suggestions, and thank you so much.
Winner from FWC is going to.
Thank you. Thank you, everybody. This is my first TAC meeting. And I'm really terrified. There are a few friendly faces in the audience, so that makes me feel a little bit better. Including like Ed Sherwood. We brought Ed into FIM. I met him at a AFS meeting when it was Red Drum. That's right. I lured him to Tampa Bay. Then he left FIM. So I didn't know I was covering all 36 years of FIM in 20 minutes. So I may have to double my time. But this is kind of in some lights a general overview, a refresher for many of you guys of what the FIM program does and how we've been rooted in fisheries independent monitoring for about 36 years. But it also towards the end, I'm going to focus in on specific projects that kind of step into some of the riverine views and stuff that that TBEP is looking at as well. So the monitoring and assessing and managing fish populations is a complicated business, and it requires a wide variety of different data formats and data inputs and metrics to do it responsibly. Our approach in Florida through FWC is we have the dependent side, which we get recreational commercial data on fisheries populations, population structure through genetic studies, ecological studies, age growth, reproduction, that type of thing from our fish biology group. And then where FIM comes in, our acronym Fisheries Independent Monitoring, we do the scientific surveys that gives us a wide variety of different metrics and measures interacting with these other groups at the same time to maximize our effort. Our mission is basically to provide, timely, accurate, consistent fisheries independent data for an analysis to managers to manage and protect Florida's fisheries. Sounds pretty straightforward, right? But it's not as easy as that. We're dealing with multiple species of fish, different types of life cycles, estuary dependent species. This is just, the typical red drum where the adults are coastal and near shore, the spawning schools, and the larvae and eggs are transported up into the bay via tidal cycles, settling out into rivers and tidal creeks. And then as they grow with ontogeny, their habitat changes, their diet changes, and they move. And it's difficult to monitor even just a single species cross its ontogeny, let alone multiple species. So our approach is basically we are independent of the fishery itself. So we design the studies ourselves. We are a multi-species program. So everything that we catch, we measure and enumerate. And we also try to target multiple life stages for especially the key species. So we're wanting to sample the juveniles of the population all the way up through the adults, all right? And what that basically means is we have to be a multi-habitat and we have to be multi-gear to access the fish at those various habitats. We can't just sample one type of habitat and one gear. That might give us some great data, but to be able to track a species just like red drum through its ontogeny, we have to change those habitats and gears to see the full picture of that population. And we do that, whether it's seagrass or seawalls or a sandy beach, and in our recent decades jumping into the offshore realm and studying coral reefs and coastal habitats like that. And that means that we have to have a wide variety of platforms, whether it's carrying a small seine into a tidal trib or chartering a large oceanic vessel to go offshore and deploy underwater cameras. Gears ranging from small seines all the way out to hook gears are underwater SBRUVs or underwater cameras, as well as now we're in the business of bottom long line. So we've got a lot of different types of gears that help us approach different species across the various habitats. Key components to any fisheries independent program is it must be highly standardized, all right? And FIM is very anal about that. Our processes as far as training new fimmers when they come in, the process of getting them to what we call a PI level or principal investigator. So they're leading trips. There's a lot of standardization and cross-training through our various field labs across the state. That gives us that broad spatial scale. We're in most of the major estuaries since 1989. Some of them not quite as long, but we've had that consistency and a broad temporal scale. So we sample on a monthly basis for the most part in all these different habitats and estuaries. As far as long-term consistency, we've got that. We've been, existing for 36 years. There's been shifts in time because you learn and grow, but that's all been, tested and gear tested, and that allows us to make those shifts with good conscience. As Bob McMichael used to say, that's why he never sleeps at night, because but he sleeps now. I know he does. And this all must be based on a robust statistical sampling design. Basically, this is how, when we say, hey, we want you to go into this bay, we found a chunk of money, this is what we would do. So we would form these logistical zones. Here, the main zones in Tampa Bay, A through E. So these 5 logistical zones. How much area can you sample within a given day in a mullet skiff, right? And then those are gridded 1 nautical mile by 1 nautical mile. And then each of those grids is broken down into 100 microgrids. That's the basis of our site selection, is the microgrid in most of these habitats, in the bay proper, as well as in the riverine habitats. Each of those microgrids is then habitat evaluated. So does it have mangroves? Does it have seagrass? And all those are fed into our site selection process then we can implement our stratified random sampling. So we may stratify or weight towards overhanging or mangrove shorelines, but we're still sampling those areas, the seawalls and the sandy beaches. And this is just a zoom in on the Manatee and the Braden River. You can see how we have that gridded. And so the site selection is fairly similar there as well. This is just a graphic. It's not exhaustive. This is something I stole from a previous presentation, but we've done dozens of riverine studies in the past 20 years. Some of it we've competed for money. Some of it has been given to us. Hey, can you study this or this? Most of this is, minimum flows, working with Swift Mud and TBEP and HBMP, several different ways. And there's a slew of stuff that we've done on the East Coast as well. So this is basically applying this FIM mode of sampling and standardization into these different systems to learn about those fishing communities and what's going on with, freshwater withdrawals, et cetera. And at each of these random data points, okay, whether we're offshore setting hook gear or we're in the Alafia River pulling a trawl, has a myriad of information that we try to collect at every single data point. So we've got location and habitat characteristics, very detailed habitat characteristics, water chemistry, weather, and then of course we identify and enumerate and measure all the fish and macroinvertebrates in these catches, or at least a subset of those, right? So it's a massive database done in a consistent manner. Our bread and butter from the beginning, when we were originally called juvenile fish, was the basic theory that trends in juvenile abundance or recruitment are reflected or can be an early detection of how the adult cohorts are going to do. So this would give managers an early warning tool, say, we've had low recruitment of snook for 3 years or whatever, then they can possibly predict that in advance. So our data kind of allows us to do that, and we can break it apart by size, like we've done here for snook. So this is in Tampa Bay. You've got the juvenile snook less than 100 millimeters standard length, and the different gears reflect the habitats that we're in. So you've got river seines, and then the 100 to 300 is kind of a new metric because we got some new funding a few years back to look at age 1 snook. There's like this little gap between the juveniles and the subadult adults that we caught in the larger gear. and we expanded habitat again that allowed us to monitor those. So those are tracking the age one cohorts within the population. And then the bottom one is the adult snook. And we do the same thing for red drum, okay? And we could do this for any species, per se. So we can look at juvenile recruitment and model these indices of abundance across time to learn about these trends and how populations bounce back. Jumping back to the snook one example is the subadult adult. You look in 2010, that's when we had one of the most recent cold snaps, which really hit back the snook population. So this is a natural perturbation that really damaged the population. Any guy in a mullet skiff could drive out there and say, hey, there's a lot of snook that died. The population took a hit. Anyone could say that. But what we want to know is how do they recover and how soon do they recover? So our technique allowed us to look at Indian River Lagoon, Charlotte Harbor, Tampa Bay, all these different areas at the same time and track it on a monthly basis to allow the managers to know, hey, it looks like Tampa Bay's bounced back, we can open it up. So we could at least provide them that kind of information just by doing what we do. Just keep chugging along and the data will be accessible. This is another way that we use, it's just a standard fisheries technique where you just take links and counts of fish over time in a given month. This is data, a decade of data from the Little Manatee River, not really specific to what I'm talking about today, but we use these to track cohorts. And more importantly, we look at abundance in given months, and we look at when the size frequencies of those young of the year fish are actually more prevalent. So we can, this not only initially lets us know, hey, this is the area of peak recruitment for red drum in the Little Manatee River. We can also track these kinds of things over time or from system to system to see with, like climate change, are these recruitment trends, are they being more protracted? Are they squishing in? What's the variability, from latitudinally from the upper Gulf, East Coast, West Coast? It's just a standard tool that we can use and we do use often to see how recruitment is doing and when it's occurring. A great example of kind of putting all these pieces together was a study that I was involved with a few years back. It was funded by Marfin, and I listed the publication there. We basically repeated this methodology by these two guys, Murphy and Crabtree. I don't know if you heard of them. That didn't get much of a laugh. I thought you guys don't know who Murphy and Crabtree are. Okay. Yeah, we got to talk. Yeah. But basically they used spotter pilots and commercial purse seiners in the coastal waters off of Tampa Bay. That's where the bull reds, the spawners, that's where they live. Okay. And we were able to strike 6 schools during our study period. You can see the little scoop goes in, they subsample that out, and then we would process all those fish for a wide variety of things, mercury and reproduction and genetics and not just age, which was the key part of this study. But you can see that our study is up top. This is just the age frequency. On the bottom is Murphy and Crabtree, which was done a decade earlier. If you remember, red drum populations had basically crashed in the 80s and Florida was right on it. There was a moratorium of commercial fishing. We went to 1 fish, okay, per person per day kind of thing. And, when Crabtree and Murphy did it, they saw very few fish over 12 years old. That's a red flag for a fish that can live to 40 years, right? So they were definitely overfished and getting pounded. We repeated a decade later, and you can see that a lot of those age classes, the mean age went up. These plots are significantly different as far as the age distribution. And you can see the ages from 12 to 30 have really started to fill in with 10 years of restrictive regulations. Before I retire, I'd love to go back out there and take another snapshot again to see how it looks now. And maybe we've got more fish into their 30s. But this is just a great sign that more fish are escaping the bay and the fishers and making it into that adult population coastally. One cool thing, this is the multi-gear multi-habitat. So we look at red drum with the Hall Saints. So that's a bay inside Tampa Bay kind of thing. So those are the fish that have come out of the rivers at about 18 months. And now they're in the bay. So those are age 1, 2s, and 3s. And then the age structure of the trammel net is more of a focused, like subadult. Some of them are mature, most of them aren't. That gather down like Fort DeSoto and down on the bulkhead on the south part of the bay. You guys have probably seen those before. And we would target those with trammel nets. And that age structure of that is usually 2 through 4. And then once they mature, they move offshore. So you can see how those age classes relate to what was happening in the adult population offshore. Linking this up, which was our hope and dream when we started this, we look at our juvenile IOAs, our indices of abundance of red drum that we calculate, and we look at these huge peaks in recruitment or large cohorts in 91, 95, and 2002. And what I did is I took the ages of the fish from the different gears and then back calculated their birthdays, right? So now we've got birth years laid out for those different gears. So the Holstein in the bay, the trammel net, and then our work and Murphy. And then you could see how the those arrows were supposed to come down real fancy, but they didn't. So, but they're there. And so, and the thing is it's not perfect, but it does show that these large recruitment events that we have are being perpetuated into the subadult, even adult population offshore. So it just makes the riverine work and habitat work that you guys are doing and looking into even more important. It means that those are protected areas that we need to take care of, because that feeds into what happens on the very end of it. And this is just one example, one species that proves that. I've looked a little bit, just a quick view into the key 2 species for all the rivers. So this is Hillsborough, Alafia, Little Manatee, and the Braden River are the yellow dots. So this is just another example. This is just general abundance from our small seine data in the river. So it's probably, variable. We have certain years or periods that we have peak abundance, and those are probably driven by juveniles. So these are all sizes of red drum that are in that gear. So for our IOAs, of course, we narrow that down so we can get rid of a little bit of the variability. And same thing with snook. Snook is even more all over the place, but you can see how the abundances over time can be tracked for snook or red drum or sea trout. Any species that you want to look at. This is and our data can also be used in this manner. So this is like mean richness. So the numbers of species that we caught by the 5 different rivers that we just saw for snook and red drum, and you can see that it looks like richness has kind of declined through about 2010, and it's kind of leveled off in most systems. But we can see how these, like the Braden River is the orange squares. They actually have the higher mean richness than a lot of the other areas that we've been in. This kind of adjusts for the sampling effort difference too. I'd like to close with some specific research that Mandy Tyler Jedlin is kind of heading up in our group now. We're back in the Hillsborough River. I can't say that Fim is excited, but so we have a little bit of history in there. Of course, you guys know the Hillsborough probably better than I do, and it's a primary source of water for Tampa. So it's an important river and tributary in Tampa Bay. We got involved back in 2000, and we were in there for a little bit more than a decade. This was funded by HBMP, and we were just basically looking at fish communities, doing the FIM thing, using monthly sampling, the small seines, the river seines, and our trawls at the time, and looking how that kind of those compared with water quality and ecological factors within those systems. Presently, we jumped back into the Hillsborough. TBEP is funding a 5-year study. We're in our 2nd year right now. We got rid of the trawls, so there was some back and forth. You have to do that if you have this much money. You want to get the most bang for your buck, so you look at what the trawls produce. Luckily, we had a decade of data to look at those 2 gears and figure out which one was going to be the best to use. So on a monthly basis, we do 2 river seines, and each river mile, you can see how it's partitioned there. Objectives are basically what they were before. Let's look at species competition or composition, distribution, abundance trends, and relate that to river flow and habitat, that type of thing. And eventually, of course, the developing a riverine neckton index. So these are just base data from 2024. All right, these top 10 species make up about 90% of the total catch. Right, so there's no surprises here. You know, it's most of the abundance is driven by small bait fishes, silversides and killifish and mullet, that type of thing. You can see the percent occurrence is the percent of hauls that species actually was present in, and then the percent composition is in the middle. These are selected taxa. So these are species that are of commercial recreational importance. Striped mullet, blue crab, spotted sea trout. You can see the striped mullet, you know, wins the award as far as being the most prevalent in our seines within our first year there in Hillsborough. And this one, kind of feeding back to some of the invasive species talk, is quite interesting. The Mayan cichlids were exploded. And just an interesting fact, like, I know it's not a huge number, 334, but like prior to that and all the other sampling that we've done, they've only caught 6. Now there's 334. And it's the similar trend in some of our other riverine systems as well. So the invasive species are there, but it seems like it's kind of flip-flop of who's taken over and who's more abundant. So in conclusion, FIMS, hopefully we're going to keep doing what we do the same way in a standardized method. Our data are being used continually for the new management by region plans, which what they have for snook and red drum and spotted sea trout now, and of course are feeding into our stock assessments. It's been used for many years with the TBEP neckton indices, and we are excited to have our data being considered and looked at to help them drive the same type of neckton indices and stuff in the riverine systems that we're in Tampa Bay. And with that, those fishes, thank you.
I'll just do one note of clarification about the river sampling. The reason that we're funding the Hillsborough River is that's the only major river that wasn't sampling consistently. So they were already sampling the Fire River, the Manistee River, and Manistee River. The Hillsborough River had that 10-year gap. So in order for us to develop a riverine index for all the rivers that lead into the bay, we really need some data from the Hillsborough River. So that's one of the reasons that's as well.
Yeah, thanks, Carrie.
I have a couple of questions. One, how are the zone boundaries determined when you guys first did that design?
Yeah, well, I can't say it was done on, you know, like salinity kind of regimes, but if you look back at some of the early work, like early work, like in the 40s and 50s, Bigelow and no, Woodburn, there's a lot of the older papers. I know that we looked at those and they had kind of had upper bay, middle bay, lower bay kind of thing. And then it's kind of purely logistical. So you're saying, okay, we're going to, you know, draw it here, cut it here. So, I mean, we're doing the same thing, documenting water quality, all that sort of thing in those different areas. But a lot of it was logistical, but just by proximity of those zones, it kind of speaks to the ecology and the species that you're going to see in those areas and the habitats. So, but the key is it's all included. Okay, we didn't say, well, we don't want to go up past the Courtney Campbell. It's too far to drive, and you know, we're just going to see the same thing up there that we see down there, and we all know that's not true. So a bay is not a bay, or a river is not a river, and we learn that by that all-encompassing kind of approach.
Yeah, that we change boundaries over time to be more consistent with like free programs. So we could just go back and reanalyze and say, well, you know, these assemblages fit here versus somewhere else. I mean, you gotta be careful with that, because I know you're, you know, your sample design is based. You have data. So
Absolutely, yeah. I mean, unfortunately, there's never like an endless bucket of money, right? So when you have a bucket of money, it's like, well, this is what I have in front of me. This is how much area I have to cover, and I want equal sampling effort proportional in each of those zones. So then my data actually means something. But there's been times, even with the riverine stuff, you may be tempted at times to say, well, we could do so much more in the bay if we just ignore the rivers. But McMichael had that vision, and he knew the importance of those areas for recruitment stuff. So we knew we had to stay in those rivers. Like Carrie said, we couldn't stay in all of them. And you saw the graphic with the dozens of different systems that we've been in that are invaluable, but there just wasn't enough money or people or resources to maintain that long-term databases on those areas. So you get little snapshots here and there. The same thing happened in Florida Bay to us, where we were in there for X amount of years and the money went away, and you know, other things happened. And now we're kind of delegated to just snapshots of those. Sometimes if you similar methodology, you can still get a picture of what's going on, even though you're not there on a monthly basis, kind of thing.
well, despite the funding challenge, this phenomenal program. My second question was like, how does this compare to like some of the other states in the Gulf Coast and then elsewhere in the country? Like, this seems to be like gold standards. Are there other places too that do something?
There are other states that have fisheries independent collections and stuff. And I don't mean to brag, but I think we're the best. We were based back in the late 80s. We were based upon a model in Texas. So Texas had already was doing a certain amount of fisheries independent work. And I know McMichael was familiar with them. I think he even went and visited them. So a lot of the stuff we did early on was modeling what they were doing. And we did extensive gear testing, different types of gears, especially as we migrated from not just juvenile fish to catching subadult adult. So it's figuring out how to, you know, take that money in the bucket and get that broaden that overlap between the small seine and the large seine. So now we're getting that full level of ontogeny, you know, for the key species that we're looking at. So North Carolina, when I was there, but a lot of it's just seasonal. I worked in North Carolina for a while, and they did fisheries independent shrimp stuff, but they would only go like for 2 months and pull a few trawls, and that was it. It's because it's labor intensive, it's expensive, so a lot of states don't want to or can't just afford to put that into that. So we're fortunate we have that in Florida.
To get at your comment about the different zones and how they're split up between them. So when you look at the connected index, we actually partition that based on the estimate. So it is Hillsborough Bay. So we have taken that data and used it, you know, to our purposes. You know, sometimes the sample sizes are not similar, but it's.
Yeah, question on.
Mine.
The program is now 35 years old. And so we've seen changes within Tampa Bay with tropicalization and transition to our vegetative community. Does the universe and the habitat characterization get updated within its film universe with selection? Or have you observed that transition of freshwater to saltwater, salt marsh, the mangrove, and the sampling and distribution adjust for that the shift that we've seen?
Yeah, I mean, the actual zones and grids that are included, that's pretty solid. Okay, but we always have a review within each system with tidal change and that type of thing. So if there's certain areas that, hey, there's no longer seagrass in this area, or the mangroves are all cleared out in these microgrids. So we're always doing smaller changes or tweaks to the master database that all of our site selection is based upon. So we can, you know, better select and stratify. But you know, if we had a point that 10 years ago it had mangroves and that wasn't adjusted, if the PI gets to that microgrid, they would spiral. We have a random spiral methodology that would allow them to spiral to the proper habitat that they need to sample. But so because we're sampling these same areas in the standard method, it does allow us to track changes, with climate change. And, we just published a couple papers on snook that have exploded in Cedar Key. So we've been able to, it's so cool. We've been able to document they're not here or they don't exist above Tampa Bay to, oh, we found a snook. And now they've got breeding, healthy populations up in that whole area. So it's pretty exciting that our data can pick that up and document it.
Basic development assessment business. Now to hear you say they're in Cedar.
Yeah.
Yes.
All right.
You got a question online?
Oh, I got it. Oh, okay. Oh, I can't see it here.
This is Randy Edwards. Am I on?
Yeah, good morning, Randy.
Yeah, well, I want to give my regards to Brent and Brent. And just for your information, I was thinking back, and my first recollection of Brent was, I was thinking 35 years, and he corrected it's 36 years, back when Brent was the first bright-eyed, enthusiastic fish biologist working at, that was before there was a FRI or FMRI or FWC. It was back at the old FDNR Marine Lab. And that lab was headed by our dearly departed Karen Steininger, who was, I think, has a role in all of this FIM work because she would have to approved it. Anyway, at that time, I was working in parallel with Bob McMichael, who was working on red drum and snook juvenile habitat and populations in the Little Manatee and the Alafaya, while I was working on the same issues in the Manatee and the Braden River, studying redfish and snook. Bob then developed the so-called FIM Tampa Bay program. Now, at this point, there seems to be kind of a confusion here about FIM and FIM. There is the FIM program that Bob developed for Tampa Bay and then extended to many other bays like Sarasota Bay, Charlotte Harbor, and so forth. That does the standardized sampling, and then there are special FIM programs, but they're all fishery independent monitoring. And I've always been a great fan of and supporter of fishery independent monitoring. But people need to realize that back when Bob McMichael proposed and developed and implemented that FIM program in Tampa Bay, about 2 or 3 years into the program, they wisely convened a meeting of biostatistician type people to evaluate what the potential statistical strength of the FIM program might be. And at that point, their conclusion was that it could detect changes, but only very large changes. It could detect large ecological changes, such as switches from a benthic based energy flow to a planktonic based system, and it would require comparison from one decade to another with changes as large as 50%. That was what the conclusion. There has never been another evaluation like that, and I think there needs to be another one. They've probably found that they can do more than that. But there is a big problem in that FIM is being regarded as the end all by many people. For example, I have a member of the TAC, Sarasota TAC committee for 39 years now. And in the last decades, the Sarasota Bay Estuary program has done nothing, absolutely nothing to evaluate, study, monitor, or quantify fish populations in Sarasota Bay after providing funding to the FWC FIM program. They think that solves the problem. That does not solve the problem because it doesn't have that statistical power. And I'm not criticizing FIM. I'm criticizing those who unrealistically think that it can solve and handle all their fish programs. And so within that view, I urge Tampa Bay Estuary Program, Sarasota Bay, and all others to not just simply rely on that. And then further, with regard to the rivers, looking at the data that Brent showed, if you look at that data, and well, more importantly, back about 3 years ago, 2.5 years ago, Brent sent me some FIM summary data for the Braden River. Some of you may know, but probably very few, that the Braden River, in my experience, my observations, has undergone a severe decline. Severe I would say on the order of 2 magnitudes in terms of the fish populations that I can see from my backyard, and that there's no explanation for. And here gives you an example of the power of FIM for one of the tidal rivers. When I got that data from Brent, I think it was back in the years of 2022 and 2021. The number of snook that were caught in the entire year for 1 year was 7 snook. That includes early juveniles, yearlings, subadults, and adults. 7 snook. The other year that I got the data was something like 14. It could have been 17. Well, when I did my study of the Braden River and the Manatee River, I could catch at a proper kind of habitat with the proper gear. It's not the kind of gear that they're using. I could catch 3, 4, 5 times of that many snook in one seine haul. The FIM technique is not suited for looking at juvenile populations in tidal rivers. And so the reliance on that data simply is just improper and something else needs to be done. So I've tried to get somebody to look at this Braden River issue for 3 years now. I've talked to FWC, I've talked to DEP, the Water Management District, the Manatee County, and some conservation groups, and nobody is willing to look into it. It's a severe problem. I walk out my dock. I'm going to show you my video. Are you seeing my video?
Not set up to share in the room.
Well, anyway, I can look out at this water all day long from sunrise to sunset, and I have not seen more than 4 schools of mullet in the entire year. I have not seen more than 10 mullet jump. I could, in previous years, back before, say, 2022, I could see dozens of mullet jumping in a matter of a few minutes. I could see schools of mullet, many schools, passing by at the same time. I could see dozens of snook busting bait. I could see huge schools of bay anchovies off of my dock that were being attacked by ladyfish. Huge schools of Jack Crevalle that come up there and tear up those bait, busting out and over the water. None of that happens anymore. Not for the last 3 years, not a bit. I used to walk out on my dock. I would see huge schools of mojar, juvenile mojar, and other benthic fishes. Now I walk out, I see none. I used to put out a trap for catch those small mohars and other fish for bait. I would catch 3, 4 dozen in a night. Lately, I put out a trap, and if I catch one small killifish, I would be surprised. Now they're non-existent. I mean, I could go on and on. I have dock lines that suspended off of my dock to a little pontoon boat that's there. The dock lines dip into the water and they're covered with paraphyte and other algae and other organisms. And they would be covered with small fishes that were grazing off. That, okay, I understand. This is taking a long time. But we need to look at these tidal rivers with different techniques and just not rely on FIM. I'll conclude with that.
Yeah, thank you, Andy. I know my time's running out. I want to just address a couple topics. Yes, we did go under an AFS statistical review early in the program, and that led to several changes in our approach at that point in time. Again, the bucket is only so big. So when you're doing that kind of thing, you have to figure out, you do as much sampling effort as your money allows. More data is always a great thing. And, if TBEP and other managers had access to multiple data sets for fish, that kind of thing, I'm sure that they would tap into those. But it seems like for the most part, FIM has monopoly on that, or at least the longest, most consistent database. And I would argue the point that you say that the river seine is not a useful gear to manage or monitor fish. We've got hundreds of peer review journal articles that have been published, and it's used in our stock assessments as tuning indices, as well as the new regional management. So that data had been reviewed and are done in a consistent manner. Just a few days ago in the Braden River, our crew caught 25,000 anchovies. So I just suggest that the danger of spot viewing, that's why we do FIM, we do multiple random sites. As you know, that gives a much better picture of what the whole of our population is doing, not just in a specific point. Okay, so more data is a good thing. Also, we have done power test analyses many times since that AFS review. It's something we constantly do to look at and try to move our sampling effort around so we're getting the most power that we can out of the samples that we can afford to do. So.
Yeah, I'm not disputing that. I agree with that, all of that. So, that's was my point. That I'm not criticizing what is being done. Just the idea that people use it too broadly and as a solution. So, yeah, I have a specific question on your Braden River snook chart graph. You show error bars. What are those error bars? Are they standard error? Or two standard errors?
Sorry, Brent has left the podium. It's a single standard error.
Yeah.
Randy, just let me pose a question to you. What would you propose moving forward to address this issue that you're seeing?
Well, I think that somebody, if FWC, maybe in collaboration with the Water Management District, with maybe FD, come in here and figure out what's happening. I can't figure it out. It is a very complex problem. I'm looking out at the river and there are crab traps, and fishermen have been harvesting crabs all through this decline. And there are times when certain fish move into the river. Huge schools of striped mohara move in here after the first coastal. There are three old dump sites on the Braden River and on this side of the river. The river is really two rivers when it gets down to the braided portion. There's the one that's influenced by Gap Creek, and there's the other main channel that's on the north eastern side. We need to have somebody come in here and do something. But it goes on for years and years. And if you can't figure out what's happening here, it can happen elsewhere. And it's important, even here in this section is an important habitat. I know that from my studies. Somebody needs to do something and not just just kick the can down the road, as I have recently said.
Well, Randy, your comments are heard. We definitely appreciate you being here. We are running a little short on time, but before we move on, I do want to put it back on the TAC. Just take the temperature on this and maybe just put it out there. How do we feel about this? Is there a path forward on this? Is this worth pursuing further? Obviously, we don't want to kick the can down the road if this is a real issue, but one of the goals of bringing this in front of the TAC is to see what other folks think, given the information that Brent has provided, given the information that Randy has provided. Does anyone have any comment on this? Is there a path forward on this? Yes, Tim.
Just real quick, as one of the ones who prepared the AFS report in 1995, AFS official response was, don't change a thing with the money that you have. Now, give us more money. I'm sorry, I'm not doing it. Please get them more money and they will do a lot more by increasing things. That's what it comes down to. With the money that is available, AFS said, do not change a thing.
I'm not suggesting anybody change the FIM program. That's the regular monitoring thing. I'm talking about fishery independent monitoring on a specific base, looking at specific problems.
We've had observations of decline in particular the data that has collected that represents the extent of evidence that we have to evaluate now. So at the time, you're charged and we give you the responsibility estimate. Given what you've heard from observations on or seen from this data, are there enough pieces of information for you to suggest that this is something that we ought to be assembling a team to evaluate a special study to advance further to be able to address what may or may not be going on in this segment and what causes may or may not be? You've heard some ideas about what potential causes might be. Is this a priority for the TAC or is it not a priority for the TAC? Because we ask you all to sort of help us then identify the projects that are worth pursuing, whether it's resources that we receive through our work plans or grants that we all go out together to collaborate. But as a program, the Estuary program does not have the staff, the boats, or the nets to do any of the sampling that's sort of being envisioned right now. We would need a team of people who are interested in advancing this further. And I'd also just put to you to think about this, not just from the problem that Dr. Edwards has identified in your assessment of that, but also imagine yourself as observers within the watershed. When you encounter, an observation or a question, you would like to be able to bring it to the TAC and get some sort of collaborative assessment and support on how to move forward. So this, right now, we're talking about the Braden River, but in the future, we could be talking about another type of tributary or something else. The role of this body, right, is to help us vet which projects we need to invest more in to understand better, and which ones, might be more appropriate for others to invest in, or maybe given the data that we have, it doesn't rise to the level. So that's the sort of feedback for you all in the room to sort of provide that perspective on. It's not, any one person for
those comments sound very important, but they're practically inaudible online for your information. I would love to hear all that some other time or some synopsis of it, but I'm sorry, but it means nothing online here. You just can't hear it.
just the comments were more for the room.
Yeah, Brandy, sorry about that. We were having some AV issues today, but the comments are more for the room. Maya just sort of articulated the role of the TAC and how to bring these sorts of issues in front of everybody, being that, TBEP is limited in staff and resources. And so we see this as a vehicle to do that, not just for this particular issue, but more so in the future. How do we bring these issues to the group as a whole that can actually move the needle on things?
But I brought this issue over a year ago to.
Yep. We got a question in the room, Randy. Hang in there. We're bringing people to the podium now.
Thank you.
I was just commenting that in response to Maya's request to get, recommendation or thoughts from the TAC on whether or not they felt that moving forward with a special study on the Braden River, that if there is a comprehensive independent monitoring effort that is currently being undergone within all the tidal tributaries and now including the Hillsborough River, and that at this point in time, there hasn't been evidence that's been presented to suggest that there is a degradation or an impact on the fisheries community that would suggest that it is an area that would require additional study at this point. Until we see that within that data, I don't think that it is an area that we need to sort of be distracted by, while there's many other areas within the bay that do need that focus.
Well, I want to point out that there is such a thing as observational data. Data does not always have to be counting hands-on analysis. And only time that observational data should be disregarded is if the observer is unqualified or untrustworthy. And that's basically what you're saying. When you have somebody who has studied this river, lives on this river for 39 years and has observed it daily, hourly, and then you say there is no information. That is incorrect. And I just, it's almost a personal insult to say there is no data. It's observational data.
Hey Randy, this is Ed, and that was a comment from one of the TAC members. So I think what we're trying to do is engender conversation among all the TAC members. So when you personally attack another person's observations, you're almost doing the same thing you're accusing others of doing. So we're trying to get feedback from the entire TAC on whether or not this is a real issue that we need to pursue with additional funding or resources or collaborations. And that is one opinion in the room. You're another opinion in the room. We're opening it up to the floor for others. We don't want this conversation to be dominated by any one voice. So I just want to leave it at that. I know we've kind of like prolonged this conversation, probably a little bit longer than need to go, but I do want to open it up to the floor for other TAC members. If there's opinions on how to move this issue forward, I'd love to hear them. If not, we have a couple more agenda items to tackle. So. Any other comments?
Hey, Randy, this is Carrie. Just one more comment. You know, this is something that obviously we care about. We care about the estuary. We care about the health of the fish populations. And we are moving forward with developing a riverine nectin index, which we'll be able to use in some of these situations as kind of an early indicator. And that is not, we haven't figured out the methodology for that yet, but I know that we're going to talk about how it's going to be, you know, specific to each river segment. We're going to use all the data available. So we are moving forward with looking at additional data. And also just to say, you know, if there are any university professors or you know, students that might be interested in this problem that you've brought to the TAC, you know, more studies going forward to look at specific issues, you know, that would be a great place for some folks to, you know, come up to the table if they're interested as well.
Anyone else want to come up to the podium? All right, well, in the interest of time, you know, we should definitely keep the agenda rolling.
Kind of playing off the point that Carrie made about the riverine necton index that's coming forward. And as you know, the different metrics that are involved in that, we don't always have all the time and the staff to play with all the specific zonal data. You know, if we have a specific research project that we're doing or funding, that kind of thing, we dive in deep. And stuff that I presented today was, you know, kind of high level, that type of thing. But there's definitely the data are there. So it's kind of exciting when you guys get your hands on it and you're going through that process of looking at all those metrics in the Braden River and the Alafila and the Manatee. You'll be able to see and pick out those trends and see if you know, if a red flag comes up. But from what we've seen in our relative abundance stuff, it doesn't seem effective, but you guys are looking at a lot of different metrics. So I think that the data are there, you can use it and get, I think, a lot more out of it than what we typically do in our standard reporting and stuff. So.
Okay, we're not done yet, folks. So I've been up here umpteen times and I'm still terrified, but here we go. I exude confidence. Okay, so last time we had a really good discussion last TAC meeting about what do we do about some of these recommendations for Old Tampa Bay that are coming out of the cylinder capacity study. Just real quick, raise your hand if you were here last time in person. Okay, roughly about half. So we wouldn't be doing our jobs if we didn't synthesize that information and give it back to you all how we sort of see a path moving forward. And the goal of this talk is to relay this back to you and see what y'all think about what we're proposing. Because the TAC is just one committee of the broader management conference that is TBEP. And this is one way to sort of vet the science and how we might sort of chart a path forward for adopting these recommendations and then elevate it up to our boards as needed. So I'm going to throw out some hopefully not too crazy ideas of what we think we could do moving forward. And I'm going to get a temperature check in the room of how we think this looks. So just a quick overview of the Assembly Capacity Project. I think most of y'all are familiar with what this was about, but there are essentially 4 different tasks. As you guys know, Old Tampa Bay has had its share of problems over the years. And so due to some sort of regulatory exceedances that happened, we were obligated to do this study. And so one of the main goals is to say, is the current existing management paradigm for Old Tampa Bay specifically appropriate for managing that system? So that was the first task of the project. Second task is doing a deeper dive into the different data sets. What are the existing indicators, targets, and thresholds? Are they still appropriate? Should we be looking at other things? Can we revise our approach to more effectively manage the system? Task 3 was looking at existing management interventions to hopefully get Old Tampa Bay back on track and then suggest a path forward to continue doing those interventions or alternatives that could be suggested to get Old Tampa Bay in a place we wanted it to be. Task 4 we didn't quite address. So what is coming out of this whole project is a set of recommendations that are just that, recommendations. Then we need to vet them through our different committees. So there were 4 primary recommendations that came out of it. These 2 in particular are management-based recommendations. The other 2 that aren't highlighted are more in the realm of regulatory and handled by other committees. So last time we talked about these 2 things. First one was, should we adopt complementary seasonal subsegment chlorophyll A targets for Old Tampa Bay? And then the second one was the recommendation that we should restore at least 175 acres of oysters in Old Tampa Bay. And as I was just sort of expounding on, the TAC really is the place to have these discussions. And ultimately, if you read our roles and responsibilities document, we want to provide counsel on these things to other parts of our management conference to actually implement these things in reality. So last time when we kind of went through each of the 2 major management recommendations, what I did was I gave an overview of what it was, and the idea was to have the different groups understand what the recommendations were and sort of get a sense of what was the evidence to support that. And then each group had some discussion time to think about it. And then we kind of did a round robin feedback to us about what were your thoughts on this? Is this appropriate? Could it move the needle? That sort of thing. And then ultimately, we're going to take that information back to our management board and get their take on it. So this is our chance to refine that if we still think there's room for that, or if we like what we're suggesting, we're just going to run with it. So we need feedback. Please don't be silent on these things if you think there's room for improvement. We posed a set of questions that we had, handouts that we gave to each group to, again, look at strength of evidence of the recommendation. Could it be effective? Do you support it? Why or why not? And just sort of the wild card, any additional considerations to improve it if you didn't agree with anything that we were talking about. So what I ended up with was 13 handwritten, sometimes illegible sheets from the group that I had to synthesize. And if you know anything about me, I have friends I have a friend called Claude that is my AI friend. And I had Claude read these sheets for me and summarize it into a nice, tidy spreadsheet. Say what you want about AI. I vetted the information. I looked at it. It was correct as far as I could tell. But if you ever need to scan a whole bunch of spreadsheets, AI is great at that. So I had all of the data there into this tidy spreadsheet here. You can look at it. And then I had a synthesis document that sort of summarized really the gestalt of everything in terms of the feedback I got from the main two recommendations. So if you want to look at that, it is linked in the agenda. You can really dive deep into what people were saying, but I'm going to do a quick summary of that. So this first recommendation of seasonal subsegment management targets for chlorophyll A, let's talk about it. This is what I'm calling cautiously supportive. This is a summary of the feedback from everybody, all the groups. Generally speaking, people liked it. It seemed great, but it came with a lot of conditions associated with it. Like, we can do it, but then what? Okay. So, things like, we need to understand what is the root cause of chlorophyll exceedances. We need to link it to, more carefully HAB events like pyridinium blooms. We need to look at alternative data sets, and we need an actual plan to implement this recommendation. What does it mean? It's not just the target for target's sake. So that was the feedback we got. These are some quotes from the sheets that I think really hit on those points. I won't belabor them, but the big thing is, I think, we want the target to actually inform some action. So what do we actually do about it? So that's kind of where I'm pivoting today. I'm kind of going on the assumption that people were generally supportive of this recommendation, but a lot of questions around what does the target actually mean and how do we implement it to actually support better management of Old Tampa Bay in a proactive manner. So this is where I kind of came up with something, and feel free to tear it apart if you don't like it, but we discussed internally, so it's not just me, but the whole idea of this is that this target should be something that is more real time and supports proactive management implementations to improve Tampa Bay as the conditions are observed in near real time as can be. So rather than our more conventional annual assessments that we do, like our annual report card, we're going to report this one on a rolling basis as the data comes available. And the idea is that if, we can look at this on a rolling basis, we can be more proactive. And if we identify a problem before it occurs, hopefully it'll be more effective at meeting the actual regulatory criteria for Old Tampa Bay as a whole. So that's the idea. This is the timeline. So like January, we do our annual water quality report card. That's when we report on the whole bay, in addition to just Old Tampa Bay. But then what we're proposing is that so this is the period of time when we have this seasonal target for chlorophyll. And so this data is supported by EPC. That's the core data set that's used to report on this. We know there's other data sets, but because most of our regulatory reporting relies on EPC, this is what was used for this identification of this new target. So we're going to report this every month as the data comes out and kind of report where we're at now and what is a likelihood of exceeding this seasonal subsegment target based on the data we have at hand. Hopefully, too, when we see a problem, trigger some sort of response from you all that can actually do something about it. Probably not surprised. I made a dashboard for this. And this is my harebrained idea of what this could look like. This is actual data from this year. We have two tabs, one for the Northwest subsegment of Tampa Bay and one for the Central West subsegment. And so we have basically, this is the data in green we have to date. And these are summaries that hopefully give you an indication of how likely we are to exceed that subsegment target. So we're obviously filling in the remaining months of this seasonal period with estimates, and using some fancy stats, we can get an idea of the likelihood of actually exceeding this target with the data at hand and what we know from past data and the behavior of Old Tampa Bay with chlorophyll. So you might see this percentage and be like, we're probably going to exceed it. What do we do about it? This is the kind of like early warning that I think we should consider, and like, when is enough information available to make a decision? Like when, like, for example, if we get a 70% chance of exceeding, is that when we do something about it, or when do we make the call? This is Central West. You'll see there's a slightly higher probability of exceeding that, and actually that is because there's a data point in October from last year when the storms came through that's really driving up that probability. So you may or may not believe these numbers, and I would love to talk with other stats-minded folks about how to estimate these things. But this is bottom line is this is informed by data as best we can to develop an idea of how likely we are to exceed these things. And we can automate this. So like every time EPC turns out a data set, it'll pull it in and it'll report this in as near real time as possible. So how this is implemented, we have this sort of early warning thing. If you're familiar with how we assess water quality and other indicators in our program, we often have these flow charts that define different actions and when action needs to be taken, whether it's reporting or some sort of management response. So I have this flow chart of how I think this could look. It's pretty simplistic, but basically the first thing we do is report these conditions through a product like our dashboard. Then we ask the question, is the target exceeded or is it likely to be exceeded? That sort of thing. If not, then we continue keeping on doing what we do to protect and manage Tampa Bay, whatever that looks like. If it's likely to be exceeded, then we do a deeper dive. We do a little more intensive interrogation of alternative data sets, not just EPC, but we can look at Pinellas County data. We can look at FWRI HAB data. We can look up in the tidal creeks, look at all sorts of evidence to get a bigger picture of what is actually going on. And one of the questions, actually, this is a point in one of our other flow charts, like, is there an abnormal condition that's driving this that is not necessarily a chronic issue that's driving water quality exceedances? That's a question we can ask. And if it's like, oh, a hurricane came through, maybe there's not much we can do about that. We'll just, take it as it comes. So one of the questions is this an actual issue to address, or is this some anomaly in the data or a random occurrence that is largely out of our control? If that's the case, then we just keep on keeping on. If not, then we actually do something about it. So this is where the rubber meets the road, so to speak, where, this is not in that normal condition. We're exceeding these things. We know it's going to likely lead to a sub or a base segment wide exceedance of the regulatory threshold. What do we do about it? And that's when we talk about management recommendations. Who's responsible for what sort of activities do we pursue, and how do we elevate that up to our broader management conference of our management board and policy board? So this is again our scheme of how this could look, but there's a lot of questions around like, when is action triggered? Who's responsible? What's defined as abnormal? That sort of thing. And I'm just posing these general questions as this is, one way to approach this. If you like it, it's not a perfect way, but there's decision points along this framework where you have to ask questions of like, like I said earlier, like what percentage is high enough of the likelihood of exceeding? Do we actually do something about it? Like that's a management decision. Where's that line in the sand? So I'm hoping we could talk a little bit about it. I don't really have like a slide of questions to you all of like general comments I'd like to have, but I'm just sort of proposing this concept of like, what is our take on this? Do we feel like this is an appropriate path forward? Because if I don't get any feedback, I'm going to bring this to the management board and say, this is what we're doing. So, yeah.
Target a sub-layer, be able to see state change within segments. And then by excluding and only using the C data in the initial evaluation, you're always going to be jumping to action 3, which is looking at the abnormal conditions, rather than just already having some of that data be part of the initial indicator or approaching the problem. So that it's taking up more temporal spatial distribution of representation that's happening, because we're updating it every year.
Yeah. Generally speaking, I'm always supportive of like the holistic look at everything, all data sets you have available to address what's going on. So I definitely feel like that should be the approach, like EPC, Pinellas, FWRI, all of those to assess it. As I said earlier, the reason this is EPC focused is because a lot of our regulatory criteria and our management targets were developed on that data set that goes back to the 70s. So we're trying to be true to, I guess, the statistical properties of that data set that were used to define our existing standards. And then we could do that deeper dive if we need to. And the thresholds themselves are actually defined from the EPC data. It was looking at, if you remember, there was like a plot of like the likelihood of exceeding the bay-wide threshold, I think, or target. I think it was looked at both as a function of chlorophyll concentration for this time of year in these subsegments. So the targets are defined on EPC. So I think that that's the rationale for why we want to use it as the initial cut. But I definitely don't want to ignore other data sets. And fact of the matter is, like, action 1, 2, 3, all the way to abnormal, that could be done in 5 minutes. We could already start looking at alternative data sets as we need it. So
We could think we could be proactive. Those see data, look at complement data sets, see where the levels are. Do that practically. Where the data sets are, correlation might exist between EPC and information. It's something we could do proactive, action.
yeah, and I did this last week, so I can add more stuff. This is just the first cut looking at it. If there's like other contextual information, like Ed was saying, of alternative data sets that would be useful, that if the TAC thinks it's useful to look at in parallel with the data that were used to define the proposed targets, that can certainly be done. Basic. Just northwest and central west. That's the hot spots typically.
Looks like we're back. Facially.
Yeah. I believe it's 2 per each, or there's 3 in central west, 2 in northwest, I think. Yep. Noted.
I think we're particularly interested in like the actions piece of it, because this is a really different way of thinking about. You're used to seeing things like on an annual scale, and then we follow the data segments. And, I think that's probably very update about what those colors mean with it, right? So I think the question that we have, back to the room, for you to see recommendations, like, if you were to get this information, with a couple month lag, would you be able to turn around and actually do anything about it in a meaningful way? It's like still not it and not helpful. Could you, have sort of like a pot of money where you could be targeted and it's crazy big? Is that even a thing that would, influence the outcomes overall? But like that's sort of like where we're at. Could you actually turn around and do something about it?
That's exactly what my question is. This is decision trees helpful in many scenarios, but this is
beyond the historical target, but any of the metrics being used that are but it gets down to the actions. Spoken with you guys, that's the sticking point. A lot of times, action on a target versus action on the threshold influences interest in doing something about those, but it's also a prioritization and a realization of what actions can be taken and reverse engineering or make your trigger point for those actions that may be different. Sweeping may have a low threshold. Borrow that term, like low tipping point to taking action versus, installing a new water treatment. They're different levels.
Can we do that?
And so my thought, having been somewhat familiar with the study, is that the action part is a critical component, and working back, developing implementable actions, and then kind of reverse engineering back to your decision point from there. Maybe a productive exercise, because through that exercise, you can also perhaps find actions that shouldn't have a trigger point. And that would contribute to
Yeah.
that flip-flopping where the action at the end versus at least development of actions and getting buy-in from these teams that can implement those actions. It's also challenging.
Yeah. I mean, that's kind of the gist of what this conversation is meant to promote. A lot of the comments we had from last TAC meeting was like, yeah, we don't want a new target just to have a new target. And I said that earlier. These are targets that are meant to promote action, and related to the last conversation, like TBAP, we can't do it. I mean, we try to coalesce ideas so that you all can do your job better, in the sense that it's informed by sound science that will promote better management of Tampa Bay. So we can present this in a way that is useful to you all so that you can define what the appropriate action is in response to achieving or not achieving a new target. And I don't know what that is, but I mean, to Brandon's point, reverse engineering it perhaps, there's always going to be things that you're always doing, but like, where can you prioritize? Like, if you know that the situation is likely to exceed this target, can you, talk to your board or whatever, and set aside some resources to act on it in a way that you think could promote or support water quality? So that's how I see it. Yeah. Yeah, and that's one of the outcomes is, is there additional follow-up that needs to be taken to identify a potential trigger that causes these things? And, one of the things that was proposed in the original project that actually didn't make it in the report was the use of sort of this upstream pollutant tracking model to more closely link downstream responses to potential causes. I mean, not saying that's the answer, but that's one option, is do this deeper dive into identifying the causes rather than I'm just going to do more street sweeping. Or not that that's a bad thing, but you want to do a little more intentional effort informed by what this target is telling you and potential follow-up analysis to identify what could be contributing to that. So yeah. 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 That's a question I don't know the answer to. And that's kind of what I'm hoping to talk about with you all is what could be done within a reasonable time frame within your budgets, within your jurisdiction to move the needle. I mean, it could be that we need to do a follow-up assessment of could these actions actually improve water quality there? I mean, some of the work that was in the report looked at that. You know, proposal of implementation of management interventions. Could it move the needle? Yes, it could. But you know, we're spread out across multiple entities, so it's all for one for all, but I know each one of you is only responsible for, you know, a small piece of the pie, so. Anyway. I convinced him.
We get flesh out more a causal link that's connected to might be the loading or something like that. And incorporating Pinellas County data, we're still not sure that the time scale is one that is actionable. To make those kind of decisions about where to need to target in production.
I heard, no, even out, but I don't think you can respond actively. So.
Well, it's helpful to know like what is your response time for planning out things? Yeah. And that varies by.
The idea of the impact the subsequent months and then they set up for the next, so you didn't have a bounce back. Because that's when you get to 2 years of cheating.
Your information is good.
Yeah.
I mean, again, it's like doing this, I can't, you know, like it's not instant, so it takes a long time. And so. That is my.
You, like some of your colleagues in the stormwater section kind of share those thoughts and things? Because you're out there like observing it, right? So how do you incorporate that information back then?
Well, so we will. It's aware. Some part of I'm kind of a project, how we are to speak.
So you're suspecting, I'm just trying to understand.
Yeah.
I'm not trying to like wait through there. So you're suspecting that it's like large scale investments that are the scale of intervention. This space segment, more so in some of like the sort of tactical or operational improvement we could be get to the smaller scale. Yes, right now, based on what is not perfect information.
Yeah, everyone wants to convert to super, but it's like a lot, it only takes a lot of time that people it, so. Again, I wish it was the switch, you know, all of the switch you have, but you know, in reality. I think it might take years to. 10, yeah, because what's.
I appreciate, you know, thinking
You can identify some of the policy things that'll happen as immediately is worth doing it. But otherwise, it's multi-year, multi-decadal. Replumbing that whole city. Won't be the background for this.
I mean, if this supports that conversation towards those longer term goals, then I still see that as a win. But it's more about, I mean, how is this most useful to you all to make decisions or promote a conversation for longer term benefit?
I mean, I still respect my read on it is that the information that we're doing long and valuable, but it has not been sufficient to make the case for you to act for nothing we're gonna do right now, like you see both in a big struggle for a decade. And the investments aren't there. So to me, whatever we're providing right now is not quite enough. It's not bad, but it's probably not enough to investigate. We're trying to think about like what could do that, understanding that it takes a long time to get stuff done. And what I'm hearing, at least from part of the room right now, is that this isn't a bad path. This might not be it. Can you help me build a direction that could be it? I'm hearing incorporate more data. We can do that. But the time scale thing is still maybe not. That was like you had to envision the future of what how you sort of pull levers within your respective areas of control. Told you need to be able to present to make that case. See if we can build it.
Really develop.
No, I mean, I'm not working for a local government utility, so it's hard for that perspective, but supporting them when they're coming up with the capital improvement plans, 10-year chunks and pushing that forward and year by year crafting out what those projects are. So it's having that understanding of more direct linkage of what potential project would influence a meaningful water quality impact. It's great, it does give you that monthly update, but will really doing street sweeping truly have an impact on the debate that's been struggling with? Or is it looking for bigger projects but where are problems that can be built into that?
Or.
I mean, right now the answer is no, we're gonna keep trying, but you have to act as if you have to manage the space segment with computers as position. That's what it is. And so what that means is you have to pull other levers part of it. Unfortunately, that puts you all in kind of a poor position because you've got these other sort of impacts that you're compensating for. But that's why we'll continue to make that case, but then we also have the reality that we bumped up against. The problem. Well, that's kind of increase going out with often. That's something that's scheduled within a year. Well, that's kind of a question for us. And I don't know that those folks are. Could you operate a structure different for a minute for, can you, there's like guidelines, right, for how different structures are operating. Can you have sort of like water quality criteria that might trigger, it's still within like certain safety zones to make you operate. With other places, right? Could we think about that in some of these things? Is that even on the table?
Working, but there are other things as well. Things that I think are very missed here. Water, wastewater, but just especially when you start looking at, I don't get it. 80+% of the loads coming out of lakes are again. They have the same. Direct discharge. So the issue that I have, you guys two issues. Those. What about all these other? So, you know, we obviously cannot have a foot protect. That's the. But, I definitely think that conversation. I do think that any construction like her. Didn't be. You know. But I think one of the challenges.
You can be off the record. Tell us what you really think.
Because. But I think Marcus, like, the big. Settle here is that. Up that. Often when you start presenting to the management policy board about, hey, what do we do about it? That's where it's a real challenge, because I don't know, I mean, you can't turn on. And right now, the structure of this start, case closed, trying to keep it. And that's probably going to be the case. For a while. Certainly with the case next year. So you've got to be bust economies of the whale. That's a tough one. Right?
Yeah.
I think maybe the takeaway word that it needs to be conveyed attack to the policy is that these conversations are ongoing. We don't have this. We can't say, oh gosh, we're gonna, you know, there's a 75% likelihood of bottom chlorophyll concentration. Everybody has to sweep the streets. But it's part of a larger. Now, I'm gonna channel my inner Jeff Green on, but you got like most of us, I think, in this group are more on the research management side, not the regulatory side. And you know, that's always been the challenge. Is you look at that, you're working on regulatory requirements, they're more interested in the threshold, not the management action, so to speak. We, I think, are looking at this more holistically, saying, well, we know one particular action is going to fix that. So we're trying to meld the two together. That's where we always sure what the
Yeah, this is what can we do how about regulatory side, because they were in trouble, but also what's the future that we envision for Tampa Bay? What are we going to do to make it?
Yeah, in 7 years. Before this occurs, and they went to small spring down simple west. Unless there's somebody. So. I don't know if it's hard.
well, and that brings up another point. It didn't bring up yet. Looking at the water quality, and that's been identified in the basement plan or different Sarasota Bay draft. You know, that's an element too that we need to consider. That may be more of an education management action where we're trying to educate folks not to fertilize. Know what's in your refined water. If you got, you know, 4 or 5 milligrams per liter nitrogen water, you should be augmenting that with fertilizer. That could go a long way, especially if these just start to go offline. That may translate into more reclaim. And we've got that. So these are overarching issues that don't necessarily translate into flipping a switch and say, oh, you know, we're gonna bust authority, we need to do A, B, and C.
Yeah, I mean, I don't know if we ever saw it that way. I mean, it seems silly to say if we're gonna bust the target, let's do this exactly with the expectation that it's gonna have some positive outcome. I think it's more just creating an incentive or moving the conversation towards looking at these bigger problems that collectively we have to manage together. And that's not satisfying, but that it's these incremental improvements that need to happen.
And you don't you can shape it. This is the issue.
Well,
Well,
I can go home now.
Then that is an helpful or hindrance to further action, like you know. It's a hindrance that we don't want to. But you think any amount of evidence that we continue to build that says there's issues, these subsegments, ultimate bay that need to be addressed over time. Various management actions, close between plumbing, certification, all those things. That if that's a helpful tool to prevent to the management topics and what I'm to so if it's an hindrance to your guys' activities. Then great for bad optics or even for your boards, then you don't want to provide it. I think it's
We got 5 minutes to talk about oysters. How do you want to handle this? Do you want to give the HRC update and we can table the oysters or just?
Why don't you just?
All right, I'll just blaze through this. This is the other recommendation we talked about. Restoring 175 acres of oysters in Old Tampa Bay. Strongly supportive, but again, lots of questions of where, how, when, that sort of thing. It's generally seen as a no regrets strategy. Oysters are a good thing to have, but again, there's a lot of practical implementation questions that came out of this. So I'll just jump to the chase. This is something that we actually have been talking some with the Habitat Restoration Consortium that Carrie may or may not mention in a second. But this does tie in with the goals of the HRC as well as our programmatic goals, because we do have within our Habitat Master Plan a bay-wide goal of 471 acres. So the question, this is the same scenario of like where, when, how much. So how do we dovetail this particular goal from the Habitat Master Plan with this recommendation for Old Tampa Bay? And so we kind of saw this as having the conversation with the HRC first of how do we develop what we're calling bay segment targets for this overall bay-wide goal and how that looks. And we kind of had two options of what this could look like, and it just varies in how you divvy up the total based on, area of habitat suitability or area where it has been in the past, that sort of thing. Cut to the chase, we didn't really get to an answer there, but we did have a long conversation about what the oyster habitat suitability index really tells you. Can we improve it? Can we develop this tool even more, develop it in a more practical way so it can better inform management? So all of these things are coming down the pipeline, but basically we did not come to consensus on how to do this, but just realize that these are conversations that are being had within the HRC, and we're still actively trying to relay that information to you all so you can stay aware of what's going on there. And this is it's all recorded online if you want to look at that and see where the conversation played out. But I don't have a simple like this is what's decided for that recommendation, other than we all kind of liked it, but how do we do it? Sort of same scenario. So I'll leave it there, unless somebody has a pressing comment about oyster restoration. Yep. Yeah, how do you do it? That was the point of the discussion last time. Just practically, how do you do oyster restoration? And there's a lot of good guidance, but still a lot of information that we don't necessarily know, particularly with how the bay varies, Old Tampa Bay versus Hillsborough and Middle, so on. So okay, that's it for me. Carrie, do you want to give a very quick?
All right.
Or
Do it. No, just summarize. I don't hear any consensus or recommendations coming out of the TAC that's ready to present to the management during policy. So at some point, to move these things forward, we will have to work them to a place where we're all like, yes, we want you to move forward, because in fact, what Marcus said at the beginning is not true. We're not just gonna take it to the management health board. That like everyone's understanding. You heard what I heard? Thank you.
Okay. All right,
All right.
real quick, yeah.
Since I have 1 minute and 30 seconds, I'm going to skip through most of our slides, but if you didn't know that the Habitat Restoration Consortium is a subcommittee of the Technical Advisory Committee. So we're going to be better about bringing things that we discuss at the Habitat Restoration Consortium to the TAC, and hopefully I'll have more than a minute to talk about it in like the next TAC meeting. But one of the things that we did talk about in addition to oyster restoration was talking about some work that some of the folks in the room that know it a lot better than me talked about at our April meeting. So Ryan Horstman did a presentation on the Alafaya Mined Lands Management Plan. And I'm going to skip over all this. We have a habitat report card. You can check it out online. We have a whole bunch of cool stuff that you can also check out online. We're looking at a logic model, but this is what I want to talk about. So this is a project that was funded by us to develop a restoration plan for areas around the Alafaya River watershed and historically mined lands. There's a lot of opportunities there. And they did a lot of information. They did a lot of analysis on source data for the different streams that were there based on old information from the 1920s, incorporating soil surveys, habitat areas, and basically looked at, okay, what headwater streams have been lost from the 1920s to now, and what restoration opportunities are there. So basically they came up with this summary map and figured out that about 13 miles of headwater streams could be restored. A lot of these had been lost over mining opportunities. It costs a lot of money, but also there were some opportunities here that we can do some spatially explicit restoration, which is not necessarily what we've been focusing on with habitat restoration. It's more been bay-wide. So the Habitat Restoration Consortium agreed with the proposal to restore at least 3 linear miles of headwater streams in the Alafaya River Basin. And there were several examples of where this could happen in the report. If you want to hear a really expanded conversation about this, go back to the recording for the Habitat Restoration Consortium meeting on April 20th. So, or the beautiful technical report. And we also actually uploaded the GIS data online onto a DOI for K&B. So the information is there as well. A lot of work went into that. So what we want from you is, does this seem like a reasonable plan to restore 3 miles of headwater streams in the Alafaya Mined River watershed? And I know I didn't give as much background as you would like to hear. So basically,
And we also want to just do a better job of communication across our committee and subcommittees, so that's part of this as well. That came out of the beginning last TAC meeting about how do we better engage and make the TAC work. So that's part of it.
yeah, so in addition to talking about oysters, we also talked about this, and this is one of the recommendations that came out. So I don't know if you want to expand on some of it, Ryan or Emily or Ray.
At this point,
Okay.
it was interesting, the idea was the entire basin, that folks, south, there's so much data to analyze. That 13 miles of headwater, is just the south, so there's a lot more opportunity. Yeah, there is multiple settings. Miles.
Yeah, and kind of where this falls into the Habitat Master Plan is, you know, some of our targets for, you know, freshwater wetlands. So they're kind of, headwater streams are kind of lumped into that, but that would, you know, allow us to hit some of those targets as well.
Okay.
Just real quick, two announcements. This is our last TAC meeting of the year, so give yourselves a round of applause. The meeting, the tentative dates for next year are on the agenda. I will send formal invites or calendar invites. But no, I will put them on our calendar, our public calendar. It's up to you to see them and come to our meetings. But just putting it out there, these are the dates for next year, tentative. If there's like something huge that I missed with something happening on any of those dates, let me know. Preferably in the next week. We're getting online. And that's it. Chair.
Yeah, the discussions were great and this felt much more like a function. That's coming out of last TAC meeting we discussed, so thanks everyone, and with that, meeting adjourned.